beautiful people, and welcome. In this video, we will start our review of factoring. Now, in this video, we're going to be talking about GCF, we're going to be talking about trinomials, we're going to be talking about the difference of squares. As always, if I make a mistake, please let me know so that way I may learn from it, you may learn from it, and we all may learn from my mistakes. Let's get started with GCF. Now, GCF means greatest common factor. So what that means is take out as much as you can from the given binomial, polynomial, monomial, whatever you have. For example, I know that I have 6. 6 can be factored out as 3 times 2. I still have my x, and I have a 3. I'm noticing that I have a 3 in my first term, and I have a 3 in my second term. So I'm going to remove it or factor it out. If I pull out 3, then inside I have 2x left over. And if I pull out a 3, I need a placeholder because if I put nothing, that means that term didn't exist. But in fact, it still is there. It just is now removed. So that means I'm going to put a placeholder of 1. And you have now removed your GCF. Let's do another one. This one has a little bit more. That's okay. So let's see. I have 10, which is 5 times 2. I have x squared, which is x times x, and I have y, minus, I have 15, which is a few different things, but I can do 3 times 5. I have x, and then I have y times y, which is y squared. So I'm going to see what is common between those two terms so I can pull them out. I can factor it out. I see a 5, I see an x, and I see a y. So I'm going to pull out a 5xy. And again, we got to make sure that we have other things to multiply with. So what's left over here? I have a 2 and an x left over, minus, what's left over here? A 3 and a y. We do not need any placeholders because we didn't remove everything from one of the terms. We have things left over. Only put a placeholder of 1 if you've removed the entire term. And this is your answer. Let's try another one. Ooh, this one has a lot. That's okay. It has 3 terms. So 18, 12, and 24. I'm thinking what's in common between? I know 9 times 2 is 18. What else is 18? I think that's it. That's all that's coming to my mind. So I have m times 4 n's. 1, 2, 3, 4. That's my first term. Then I have minus. Right, so 3 times 4 times m times 3 n's, 1, 2, 3, plus, and then we have 24, which 24 can be factored out different ways. So we're going to see what the best method is. Let's just do 12 times 2 for right now, times m, and I almost ran out of space here, so times n. I'm looking what's in common. I have a 9, a 2, a 3, a 4, a 12, and a 2. So it looks like these are not actually my factors factored because I can factor 9 more, and I can factor 4 more, and I can factor 12 more. So I'm going to do that. So there's 3 times 3 is 9 times 2. Then I have my m's, m, n, 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 n. Then I have my 3 times 4, which is 2 times 2. And then you guys, immediately after you do, some of these, you're going to notice there's some patterns. So for example, here is 6 times 2, but then you can break up 6 into 3 times 2. So I have 3 times 2 times 2 times, that's it. 3 times 2 is 6, 6 times 2 is 12, and then I have my leftover 2 for 24. M times n times n. Now that you have factored it all the way to its prime factoring, let's see what we have in common. I have a 3 in all of them. I have a 2 in all of them. I have how many m's in all of them? I have 2 m's in all of them. And I have 2 n's in all of them. So what's left over in each one? I have a 3 and 2 n's here, n squared left over. I have a 2 and an n here, and I have 2 times 2, which is 4, left over in my third term. So how do we write this? Well, let's write out what we factored out first. So I factored out a 3, I factored out a 2, I factored out m squared because there's 2 m's times n, right? M times m is m squared, and then I had 2 n's, which is n squared here. Then what do I have left over? I have left over 3 and n squared minus, because I have this minus, 2 and an n left over, plus I have 2 times 2, which is 4. Everything else was been removed. And that is how you factor out GCFs. Now, you can skip this method. Absolutely, you can skip this method. If you are able to identify that in 18, that is 6 times 3, here it is, you can pull things out just by identifying them, and you don't have to spread everything out here. Now, 3 times 2 is 6. I'm going to cross this out and just write 6. So technically, our final answer should be 6 times m squared n squared times 3n squared minus 2n plus 4 as our actual final answer, since I didn't really notice the first time that 3 and 2 were not multiplied out. This one here is our answer. If you notice that 18, 12, and 24 have 6 in common, you can pull that out. Then if you notice that you have an m squared, and m squared, you can pull that out. If you notice you have m to the 4th, m third, m to the 2nd, you can pull out an n squared. So you can skip this long method, however, it is helpful. All right, let's go ahead and move on to factoring the difference of two squares. Now, there will be a separate video to go through, I believe, 9 examples. These are just 4 more for you. So x squared, so what you're trying to do with the difference of squares is you're trying to get it into this method. Bubble square, so this is a squared minus b squared. And what that's going to equal to is a minus b, or plus, and then a minus b. So here we have x squared, so you're going to rewrite that as x in a bubble squared minus, and then 1 is going to be in a bubble squared. Now basically what you're saying is what times what itself, like for example 1 times 1 is 1. X times x is x squared. Once you have it in this bubble form, you're going to write it as a plus b, a minus b. So x is now your a, 1 is now your b. So we have x plus 1 and x minus 1 as our answer. Let's try another one that doesn't include 1. I feel like 1 is always a little tricky to see. So here's 9 and 16. 9 is 3 squared. Y is y squared minus 16 is 4 squared. Now notice 3 squared and y squared are not following this pattern. It's not just a squared. So we need to rewrite them as one term. So we're going to say 3y squared. Now we have this 4 squared remaining. And we have our pattern. So let's go ahead and write that. A plus b, a minus b. A is now 3y. B is now 4. 1 is plus, 1 is minus. Let's do 2 more. This one here I see is 25, which is 5 times 5, minus m. M is just m squared. Let's do that again. A plus b, a minus b. A is now 5, b is now m. And we have 1 plus, 1 minus. Let's do this one here. 9, we said already, was 3 squared. 4 is x squared squared minus 4, which is 2 squared. Again, this is two things. We want to combine them into one, so we have 3x squared squared. So what I'm doing when I'm combining them into one is I'm just taking the insides and just writing them next to each other. And then I'm taking the squared and just writing it once. And then we have our minus 2 squared. So what do we have here? A plus b, a minus b. So a is now 3x squared. B is now 2, this 2. 1 is plus, 1 is minus. That's our answer. All right, let's go to move on with factoring perfect square trinomials. So you have two perfect square trinomials. You have either pluses or minuses. So what we're looking, here's a thinking bubble. What we have here is either we have a plus b squared or we have a minus b squared. Now if we have a plus b squared, that means we're going to have a pattern that says a squared plus 2ab plus b squared. If we have a minus b squared, we have a squared minus 2ab plus b squared. And so what we're going to do is we're going to check first if it follows either this pattern or this pattern by checking the first and the last term to make sure they are perfect squares. If they are perfect squares, then we look in the middle term to see if they are multiples, or not multiples, if they are, I guess, 2 times the first and the third term. It's a little confusing, so I'm going to show you by example. A squared can be rewritten as a squared. So far so good. The c can be rewritten as 5 squared. So far, this a and this b squared match. Again, for both. I do see a minus here, so we're leaning towards this yellow one because we want a minus here. Next thing we have to check is if this term right here is 2 times a times b. Well, a is just a, right? So we have 2 times a. What is b? B is 5. 5 times 2 is 10. We have a. So in fact, this one matches with this one. Therefore, we do have a perfect square trinomial. So we're going to write it as a minus b squared, and we're done. Here's your a. Here's your b, which is 5. And then we're going to write a minus, and we're done. That's it. So here's your a. So this term, it just happens to be a, but here's your first term. Here's your last term. Let's change color so they're not both yellow. There you go. And then that's it. Take the first, take the last, put a square with it, and you're done. Let's try this again. 16 is 4 squared. This one here, oh, it has 2 things. That's okay. 5 squared is 25. X squared is x squared. Again, we want to have it as one thing squared, so we're going to combine this. So this is 5x squared. And again, we want to double check this middle term. So I'm going to write in a thinking bubble, middle term. So we need to check if it's 2 times a times b. So this is your a. This is your b. So then let's check. 2 times a, which is 4, times b, which is 5x. 2 times 4 is 8. 8 times 5 is 40. And then we have that x. So it should be 40x. Is it? Yes, it is. And then we want to also double check this symbol because we want to know if we're writing a plus or a minus here. This symbol is a plus. Therefore, we are writing it with a plus here. So we have, what do we have? A, which is 4. B, which is 5x, and we're writing a plus in the middle because this is a plus symbol here, and then we're writing a squared with it. Let's do 2 more. What do we have? 49, that is 7 times 7, so 7 squared. We have x squared, so it's x squared. Combining those, we have 7x squared. 1, again, is one of those very special numbers when factoring. 1 is just 1 squared. So we need to check 2 in our thinking bubble. You don't have to write it down if you want to do a mental check instead. 2 times a times b. So I have 2 times 7x times 1. 2 times 7 times 1 is 14. I have this x, bring it down. So I should have a 14x, which I do. Now we have to check for our symbol. Our symbol here is a minus. So therefore, we should have a minus in our binomial. So what's my a? My a is 7x. What's my b? My b is 1. And we're always going to write a squared here. And we are done with this one. Let's do last example here. 36 is 6 times 6. So 6 squared. X is just x squared. This one here is 49, which is 7 squared. We need to combine these, so 6x together squared. And then we still have our 7 squared, so this is now our b. This is now our a. Again, let's do a quick check for our middle term. 2 times a times b. 2 times a is 6x. b is 7. So I have 6 times 2 is 12. 12 times 7 should be 84 maybe. 12 times 7, it is 84. And then we have our x to drop down. Yes, it does match. Now we need to check the symbol. It is a plus, so that means my binomial will have a plus in it. What's my a term? My a term is 6x. What's my b term? My b term is 7. Square it, and we are done. All right, beautiful people, this has been your part 1 of the factoring review. Thank you so much for watching, and I will see you in my next video.